Welcome to my lecture. Please visit my earlier lecture on adding and subtracting fraction if you haven't already done so. In this video, you will learn multiplication between fraction and whole numbers, as well as multiplication between proper fractions. Consider multiplying whole numbers such as 2 times 3. This can be illustrated using rectangles having a dimension 2 by 3. The area of the rectangle is then equivalent to the result of your multiplication. However, you can also think of multiplication as repeated additions, adding 3 lots of 2's, giving you the same total of 6. Or you can think of this as addition of 2 lots of 3, giving the same total 6. Therefore, multiplying 2 times 3 or 3 times 2 are really the same end result. Similarly, consider now multiplying 2 over 3 with the whole number 2. You can also illustrate this using a rectangle having the dimension 2 by 2 over 3. Where each small rectangle is representing 1/3 of the shape. Therefore, 3 small parts of the rectangle make up one whole. There are 4 small shaded rectangles in total. Result of the multiplication therefore should be equivalent to adding 1 whole and 1 over 3, which is 1 and 1/3 as a mixed fraction. Hence, multiplying 2 over 3 by 2 must be the same as 1 and 1/3. You can also think of this as adding 2 lots of 2 over 3's. Applying the usual fraction addition techniques, since these have all the same denominators, we add the numerators to give you 4 over 3. Notice that this is also equivalent to multiplying 2 with the numerator, giving you 2 times 2, which is 4 over 3. Hence, changing 4 over 3 into a mixed fraction gives you 1 and 1/3, which is the same as the result we got earlier. How about multiplying 2 proper fractions together? Consider multiplying 3 over 5 with 2 over 3. Illustrating this graphically, it is a rectangle having a dimension 3 over 5 by 2 over 3. Like before, the product of these fractions should be equal to the area of the shape. Hence, multiplying the numerator 3 times 2 gives you 6, and multiplying the denominator 5 times 3 gives you 15. Therefore, the fraction should be 6 over 15. But 6 over 15 is not yet in its simplest form. 6 and 15 both can be divided by 3 as they both have the same common factor of 3. Therefore, dividing by 3 gives 2 over 5. Notice that we can also cancel 3 from numerator and denominator of the original fractions in order to give the same results. 3 divides 3 to give you 1 in both cases. Cancelling can only occur diagonally and vertically between any two numbers of fractions. Note that cancelling terms will always make the multiplication of fraction easier as we are making the number smaller, and a smaller number means it's easier to manage your calculation. Therefore, always avoid multiplying fraction before cancelling any terms. Let's now find the multiplication of 7 over 12 by 6 over 21 by cancelling the common factors. First step is to find the common factors that can divide a pair of numerator and denominator. In this case, 21 and 7 both have a common factor of 7. However, 6 also have a common factor with 21, as they both can be divided by 3. Furthermore, 6 also have a common factor with 12, as 6 divides 12 and 6 both. Picking up a pair of numbers shouldn't be really problematic, as you can start this calculation with any of the pair we mentioned before. However, use the highest common factor as much as you can, as it reduces your calculation steps drastically. Since the higher common factor is with 7 and 21 rather than 6 and 21, we divide 7 by 7 to give you 1 and divide 21 by 7 to give you 3. Now we can use 6 to cancel 12 and 6 down to 2 and 1. Assess if any new and remaining terms cancels any further. In this case, there are nothing that can cancel. So multiply the surviving terms in the numerator and the denominator to give you 1 over 6. Thanks for watching. Be sure to try the given exercises to test your knowledge. I'll see you in the next part.